Hi there, I'm Adam from CatBorg Studio. In this episode, we're gonna focus on Game Manager. Let's start our epic game development journey. So today, we'll be working with Game Manager script, which coordinates game flow, managing crucial elements like player input, win conditions, and transition between game states. Moreover, it ensures smooth gameplay, handles core mechanics, and maintains overall coherence, crucial for delivering an immersive and engaging gaming experience. Create a new game object, name it Game Manager, and reset its position. Go to Scripts folder, create a new script, name it Game Manager, and attach it to the Game Manager game object. Open up the Game Manager script. Let's clean up. Now, inside this Game Manager, we'll be using coroutines. They will allow us to suspend the execution of our script until some input from player or game. So instead of using the update void and running many iterations per second, we'll start a single coroutine and handle the main game loop with it. We'll need 4 I enumerators: master loop, beginning of the game, main part of the game, and end of game. Then, in the start void, we need to start coroutine master loop, which will yield return the 3 next coroutines in the selected order. Each of them will be started after the previous one is finished. So, if we suspend execution in beginning of the game until the player hits spacebar on the keyboard, no further code will be executed. Now, let's use some simple debug.log to check if our Game Manager script is running as expected. So, when we enter the play mode, we are supposed to get 3 messages in the console. Perfect. Now we could add the first input from our game. It will be information that the player wins. Let's add serialized field bool m_player wins and set its default value to false. Then, in main part of game, let's add a while loop. So while the m_player wins value equals false, further execution will be suspended. Hit play and examine how it's working. We can see that the game almost instantly goes to main part of game. Then, when we set m_player wins to true, Game Manager continue to end of game. Perfect. Now, let's say that the player will win when he managed to get out from the building. So, we need some element which will check if he passed through the doors. Let's add 3D object cube. Change its name to exit point. Focus on it by hitting the F key and by using the rect tool, change its dimensions, so it will nicely fit our exit doors floor. Change its material to something nice. We'll go with the same material as player, but you can add something new on your own. Now, let's drag our exit point to the hole in the walls. Remember to use the Ctrl key to snap it. Due to the fact that we are using physics for moving player, we'll use a collider for catching information on the player reaching the game goal. Start by editing the box collider size by clicking this button. Now, increase the box Y dimension so the player will not fly above it. We will use onTriggerEnter void, which needs to be included in the script attached to the game object with collider. Go to the script folder and add a new script. Name it exit point, attach it to the exit point game object, and edit it. Remove not needed elements, and let's add void onTriggerEnter. So, how does it work? When some other collider with rigid body component attached to it touch this collider, void onTriggerEnter will be called, and moreover will allow us to access this other collider. Now, we need to check if this other collider is attached to the player. So enemies or NPCs will not win the game for us. There are many ways to do it. We'll use try to get component. So if the other collider had player controller attached to it, it will return true and will do some work for us. As we need to reach our game manager and inform about player winning the game, we need some variable game manager m_game manager to grab and store a reference to game manager. So now, when the other collider was confirmed as the player, we could call m_game manager dot player reached exit void. Of course, we can see that the script is showing us some error due to the fact that this void don't exist yet. So let's generate a method for it. Now hit and hold Ctrl, then click on it to inspect our brand new void. Change from internal to public, and inside set m_player wins value to true. Let's get back for a moment to the exit point script and grab the game manager reference. Instead of going with start or awake, we'll go with something called lazy initiation pattern. We'll write private enable void and force grabbing reference during the first call of onTriggerEnter instead of awake or start. This pattern is very useful due to the fact that defers resource loading until necessary, reducing initial overhead and optimizing performance in resource-intense applications. Now, let's add a bool m_was enabled and set its initial value to false. This bool will be used to prevent from running the enable void each time when onTriggerEnter void is called. So, when enabled is finished, we're setting its value to true. As exit point GameObject is the child of game manager GameObject, when we grab a reference for it, we need to write transform.parent.getComponentGameManager. Finally, let's add checking if the script was enabled and calling enable void if it's needed. Before we hit play, we need set isTrigger value to true on our box glider component attached to exit point GameObject. Now let's hit play and run out of the building. Great! Let's add the next feature to our game manager. It will be nice touch if, in order to start, player will need to hit some key like spacebar. Get back to our game manager script and add another while loop. So, as long as input.getKey is different from keycode.space, further execution will be suspended. Great. Although looking nice, the player is able to move when Game Manager waits for spacebar, and this isn't supposed to happen. We will solve this issue by removing control over Player GameObject from the end user during the beginning of the game. And yes, of course, we will solve this issue from the level of Game Manager. We will need a reference to our player controller. So let's declare serialized field player controller m underscore player controller. Then go to IEnumerator begin of the game and write m underscore player controller dot allows for control. Of course, we can see that script is showing us some error due to the fact that this void doesn't exist yet. So let's generate a method for it. Now hit and hold Ctrl, then click on it to inspect our brand new void. Change from internal to public, remove throw exception line. We'll need some bool in order to check should player have control over player game object. Let's add bool m underscore player has control and set its default value to true. Now get back to lately added void allows for control and add input parameter. It will be bool underscore player has control. Now inside our void write m underscore player has control equal underscore player has control. So by pushing true or false as input parameter, we could change this bool value. Getting back to player controller. Now, as we track, should end user have control over player game object, we could simply stop further execution of update function before end user keyboard input will be collected. Let's write if m underscore player controller equals false, return. We adding this after clearing m underscore move vector, so our player game object will not slide endless with last end user input. Now, in Game Manager, after end user hit spacebar, we could allows for control over player game object. Let's simply write m underscore player controller dot allows for control and put true as input parameter. Finally, we'll remove control during endgame coroutine. Remember to assign player controller reference to Game Manager before entering play mode. Now hit play and check out our last added feature. As expected, player keyboard input will not be respected till before hitting spacebar on keyboard, so everything's worked fine. Now, we could also add some game starting in amount of seconds timer, so zombies will not chase our player immediately after hitting that spacebar, but after a few seconds. Let's jump to beginning of the game coroutine and add yield return, new, wait for seconds real time, 1. So this line will suspend further script execution for 1 second. If we add some debug.log with remaining amount of time, we could get some useful temporary solution. Let's scale this up to count down from 3 seconds. Seems working, but code looking terrible. Let's improve our script by using simple for loop. So we'll start with 3 iterations. During each, we'll use debug.log and yield return, new, wait for seconds real time. In order to make that working, we need to prepare a message for end user. It's nothing more than string value. So let's declare string variable. Best place will be before for loop. Name it underscore message for player. Now, simply each iteration we changing underscore message for player value for string game starts in merge with a to string value. Let's enter play mode and check out for loop. Great, we had same result, but thanks to this for loop, we'll be able to change amount of time delay really easy. Let's declare serialized field integer m underscore start game delay with range attribute 1 till 4. Now simply put m underscore start game delay here. Let's get back to Unity, set time of delay on our new slider and enjoy. That's all in this episode. Let me know how do you like this content in the comments below, and see you in the next one.